So we are back to solve question 5 of the 2015 Maths paper, and it's paper 3, so A-level. Right, so this is a question which says the equation of a curve y equals e to the power minus 2x multiplied by tan of x for x between 0 and pi by 2. So the first question is obtain an expression for the derivative of y with respect to x and show that it can be written in a form as shown. So it's a quadratic in tan of x. Immediately this should jump at you, where a and b are constants. So okay, and then this is a good habit to read the whole question. Explain why the gradient of a curve is never negative. Well, I can already see that I know how to answer this question because the quadratic term here is always going to be positive, and this term is also always positive. So that's why the gradient is never negative. And then find the value of x for which the gradient is least, and we'll come to that later. So let's get started. Okay, so y equals tan of 2x. Sorry, e to the minus 2x times tan of x, and I've written it here. And now I need to differentiate this in order to find the derivative, so taking derivatives, and I need to use the quotient rule. So quotient rule. Oops, I'm running out of space, but you get the point. So quotient rule. And that's not that. But what is the quotient rule? Well, let me make my pen a bit smaller. So the quotient rule is that duv by dx, say, equals u dv by dx plus v du by dx. And if you use that with u equals e to the minus 2x and v equals to tan of x, this is what you get. So dy dx equals to e to the minus 2x, so u dv dx, which is d tan of x by dx, which comes out to sec squared of x. And then you need to add v, which is tan of x, times e to the minus 2x times minus 2, because it's an exponential. Right? So this simplifies out to this. Now, we know that we need a quadratic in tan of x, so we can use the identity, which, if you practice enough, should be memorized, that 1 plus tan squared of a is sec squared of a. Well, so plugging that into this equation gives dy by dx equals e to the minus 2x, 1 minus 2 tan of x plus tan squared of x. And now you can factorize this because you know that this is just equal to this, right? And now a equals, so from here you can identify that is the correct form, so e to the minus 2x, and then it was a plus b tan of x squared. So let's scroll back up, and it's exactly here, right? A plus b tan of x, the whole thing squared. So then a equals 1, and b is minus 1. Okay, so that's the first part of the question solved, and that was pretty easy. So the second part of the question, oops, scribbled. Well, the second part of the question tells us that why is the gradient never negative? So we have the gradient, and the gradient is given by, let me write the gradient again, so dy by dx, which is the gradient, equals to e to the minus 2x 1 minus tan of x the whole thing squared, right? So this is our gradient right here. And this is never negative because, well, we can analyze each part separately before grouping them. So 1 minus tan of x squared here is greater or equal to 0 for all values of x. And here I made a mistake while doing the question myself. Well, it's values of x between 0 and pi over 2. And pi over 2 should not be included. Why is that? Well, because you know that the graph of tan of x from 0 to pi over 2 looks something like this. Pi over 2. This is x, and this is like y equals tan of x. Right? So this is greater or equal to 0, obviously, and that is the graph of tan of x, but the square of something is always positive. And now e to the minus 2x is always greater than 0, and that's true for all real numbers, because if you plot a graph of e to the minus 2x, what does it look like? Well, it looks like this, right? And it crosses at x. It crosses x equals 0 at 1, right? So then the product of the two quantities, which are never negative, will be never negative. So there we go, positive times positive must be greater or equal to 0 for all x. And it shouldn't be for all real numbers, it should be for x between 0 and pi by 2. There we go, and that can be included. Okay, so let's have a look at the last part of the question now, which is find the value of x at which the gradient is least. Well, we know it's never negative, and we can make a quick observation. Well, what happens at x equals pi over 4? Well, you should memorize this as when x equals pi over 4, and let me get rid of this to explain it better. When x equals pi over 4, well, tan of x equals 1, as can be seen here, right? And you know this because the graph goes this way. So x, and then tan of x, and this is pi by 2, pi by 4, so 1 is here, and the graph would look something like this, and it asymptotes to pi by 2, right? It crosses at 0. So when tan of x is 1, well, dy by dx is 0. And why is that? Well, that's because dy dx, and let me write it here, and let me make my pen thinner. Well, dy by dx equals, oops, sorry, let me start again. So dy by dx, sorry about this, equals e to the minus 2x 1 minus tan of x squared, and this we know has to be greater or equal to 0 from the last part. So the minimum is obviously 0, and this occurs at x equals pi by 4 because 1 minus tan of x equals 0. So there we go. We solved the question and we got 4 marks. However, we could do the question if you're not seeing this insight here. You could do the question by differentiating again, but this would take you much more time. So see you next time, and be on the lookout for such tricks.